Alright, in this video I'm going to be doing the problems from the Test 1 review. So let's start here with exponent rules, and I would remind you that we have three key rules that we use. The first one is if we multiply powers of some base, in this case a, we add the exponents. That's called the product rule. And our second one, if we take a power to a power, we call this the power rule, or I call it a power to a power. In that case, we multiply the exponents, and so here we would get a to the eighth. And then our third key rule is the quotient rule. Notice here we're dividing two powers of some base, in this case a, and in this case we subtract the exponents, which is not surprising. With the product rule, when we multiply two powers of a, we add the exponents, and when we divide two powers of rules, we do the opposite, and we subtract the exponents. Alright, so here we would get a to the ninth. Alright, let's go ahead and look at number 1. So here we're going to need the product rule, so we'll add the exponents. Whoops. And we get x to the 14th. Let's look at number 2. Now number 2 is really just like number 1. If you wanted to, you actually could rearrange this. You know that when you multiply, the order is not important, so we could rearrange it so we have our x's and our y's together. Most people don't do that. We just add our exponents, and without having to rearrange it, you get x to the 9th and y to the 11th. Number 3 is the quotient rule, so we're going to subtract the exponents, and you get y cubed. Now if you look at number 4, I always look at this as being like two problems in one. So notice we have our a's and we have our b's as bases. So a to the 8th over a to the 1st, 8 minus 1, we're going to get a to the 7th. Remember, anytime you have a base with no exponent written, it's understood to be 1. And of course 5 minus 4, we're going to get b to the 1st, or we just write b. On number 5, we're going to use what's actually called the expanded power rule. Negative 3 to the 5th power is the first part of this, and then we're going to take a cubed to the 5th power. So if you multiply 5 negative 3's, you get negative 343. And of course, a cubed to the 5th power, that's a power to a power. That's why we multiplied there. If you look at number 6, notice our base is everything inside the parentheses. So anytime you have a base to the 0 power, you're going to get 1. So this is just 1. On number 7, again, we're going to use that expanded power rule, so it'll be 3 squared, which is 9. X squared squared, so again, that's a power to a power, so we're going to multiply the exponents. We'll get x to the 4th. And y to the 5th raised to the 2nd power, again, that's a power to a power. And 2 times 5 would be 10, so we get y to the 10th. Number 8, notice we have a multiplication going on here between these two guys, and then we also have a power here. So order of operations tells us that we need to apply the exponent first. So I'm going to use the expanded power rule. Let me go ahead and rewrite the 5x squared, and then we're going to cube the 2, and that's going to give us 8, and x to the 4th power raised to the 3rd power, so that's a power to a power, so we're going to multiply. And y squared to the 3rd power, again a power to a power, will multiply. And so finally we're ready to multiply all this out. 5 times 8 is 40. We've got x squared times x to the 12th. So again, we're going to add the exponents here. This is the product rule. We get x to the 14th. And then don't forget the y to the 6th. And let's look at this last one, number 9. So if you look inside the parentheses, there's a lot there that can be simplified. So before you start cubing everything, I would simplify what's inside the parentheses. And again, I would think of this like 3 problems in one. Notice 12 over 6, that's just a fraction to be reduced. In fact, 12 divided 6 is 2. X to the 20th over x to the 4th, we're going to subtract our exponents using the quotient rule here, and we get x to the 16th. And then y to the 18th over y to the 9th, we're going to subtract our exponents. We get y to the 9th. Don't forget though, all of this has to be cubed. So now we'll use our expanded power rule. 2 to the third power is 8. X to the 16th power cubed, so notice again it's a power to a power, so we'll multiply our exponents. 3 times 16 is 48. And then 9 times 3, we got y to the 9th power raised to the 3rd power. Again, we're using that power to a power rule, so we'll get y to the 27th. All right, let's move on to the next problem. So now we're solving equations. Now I would remind you, we started with what I call 1- and 2-step equations. Actually, we don't have a 1-step equation here. I'll give you a real simple one, like x minus 3 equals -4. The goal here, as we've discussed, is to get x by itself. And so I got to get rid of that -3. And so I want to do the opposite of subtracting 3. So we're going to add 3 to both sides. And so then we get x is equal to -1. So that's what I call a 1-step equation. In one step, we were able to get x by itself. So that's a 1-step equation. Number 10 is actually what I'd call a 2-step equation. Notice to get x by itself, you're going to have to get rid of that 2. And since it's 2 times x, we'll do the opposite and divide by 2. And we also have to get rid of the -5, so the opposite of subtracting 5 would be adding 5. And so that's what we'll be doing. We talked about how with 2-step equations we always add or subtract first. So here we're going to want to add 5 to both sides first. And so we're going to get 2x on the left and 24 on the right. And 2 times 12 is 24. You could actually divide each side by 2 if you want, but your final answer here is 12. And I want to remind you, with equations, you could always check your answers. If you plug in 12 into this equation, you can verify that it does work. Let's look at number 11. So basically, once we talked about 1- and 2-step equations, which we just looked at, then we talked about what I call the CSI 1- and 2-step. It turns out if you do these 3 things, you'll always end up with a 1- or 2-step equation. So in this problem, notice we don't have any fractions to clear, so that's not an issue. We don't have any simplifying to do. If you look at the left side, those are not like terms. If you look at the right side, there's nothing you can simplify there. So there's no simplifying that we can do here. I is for isolate, meaning we need x on one side only. And in fact, in this problem, that is a problem. We need to, or I should say in this equation, that's going to be an issue because we have x on both sides, and we're trying to get x on one side only. So here we do need to isolate x on one side. We do need to do this I. And so we'd want to, well, I'm going to go ahead and get rid of the 2x on the right. So we just subtract 2x on each side. And so on the left, we're going to get 6x minus 10. And on the right, notice those 2x's cancel, they're opposites, and we're left with 50. So now we do have a 2-step equation at this point. We're going to need to add 10 to both sides. We're going to get 6x on the left and 60 on the right. Of course, 6 times 10 is 60, and so we're done. All right, let's look at number 12. So again, I'm going to do the CSI thing. I don't have any fractions to clear, but I do have some simplifying to do. So let's distribute on the left. We got 3 times 2x is 6x, and 3 times a minus 1 is going to give you a minus 3, or negative 3, which we write as minus 3. Now we need to bring down the minus x. Notice it's not part of the distributing that we did with the 3. On the other side, we also need to distribute. We're going to get 5 times x, which is 5x, and 5 times negative 2 is negative 10, so we'll write minus 10. And again, this 7 here is totally separate. We're just going to bring that down. Now, we got rid of the parentheses, but we still have some simplifying to do. So again, with the CSI, we didn't have any fractions to clear, but we are simplifying here. We're not quite done yet. On the left, we got a couple of x terms. Notice it's a 6 and a minus 1 are our coefficients there. So we get 5x. Let's go ahead and bring the minus 3 down. On the other side, we got the negative 10 and the 7. So we're going to get 5x and a minus 3. So this is one of those special cases. 5x minus 3 equals 5x minus 3. This is actually what we call an identity. This is true no matter what x is. Now we could get x on one side, or I should say we could get rid of the x on the right, and we end up getting rid of x on both sides. Notice we get negative 3 equals negative 3. We could even add 3 to both sides, and we get 0 equals 0. But really, once you have the left side being the exact same as what's on the right side, you have an identity, and you're going to have all real numbers as your solution. And we did discuss a way to write that in short. It looks like that. All right, let's move on to number 13. Now, if you look at number 13, there's no number in front of the parentheses. It's understood to be a 1, and 1 times anything is itself, so let's just get rid of the parentheses there. Don't forget to drop that minus 5 down. On the other side, we'll distribute negative 4x, and then a negative 4 times negative 7 is a positive 28, so plus 28. On the left, we still have some simplifying to do. So let's combine that 4 and the negative 5. We get negative 5x minus 1 is equal to negative 4x plus 28. So now I need to add 4x to both sides. I'm trying to get x on one side only. Get minus x, negative 5 and 4 is negative 1. If you want, you could put a minus 1 in there. And then minus 1 equals 28. This is actually a two-step equation. We're going to want to add 1 to both sides first. And so we have a minus x equals 29. And again, that's a negative 1. And so at this point, you can think of it as you're dividing each side by negative 1, or you could think of it as you're multiplying both sides by negative 1. Either way, you're going to get x equals negative 29. All right, we're going to stop here for the first video.